Welcome back to our series on writing an interpreter in Nim. I apologize for the delay in continuing the series. I had some construction going on at my house, which made my usual recording setup unavailable. But that is now done, and I'm looking forward to keeping up with the videos in this series. As always, this is going to be very much raw and unfiltered, intentionally stream of consciousness style. And as always, if anyone has feedback or suggestions on anything that comes up in this video, I'd really appreciate any feedback in the comments. If you like the video, then like the video and subscribe. It helps me out a lot, and I appreciate it. So we're going to jump back in where we left off. The very last thing we implemented was this treatment of numbers, where we encounter a lexeme that is to be interpreted as a number, and that's exactly where we left off over here. By the way, I made my font size larger in response to some feedback in the comments. I hope this is big enough. It does mean that, especially when I have the PDF open on the right and the shell on the left, that some of these lines will run over the allotted space, but not frequently, and hopefully isn't a big issue. But I do hope this helps with the legibility a bit. So this is literally, no pun intended, where we left off with the if is digit. Then we are going to add a token of a number, and we are going to resume right from there. So here's where we're at. Yeah, you'll recall we were in the final inning of implementing the scanner, and it's nearly complete. And that's what the author says. Our scanner is almost done. The only remaining pieces of the lexical grammar to implement are identifiers and their close cousins, the reserved words. You might think we could match keywords like or in the same way we handle multiple character operators like less than or equal to. As an example, you think we could have this case statement, case O, check if the next character is an R, and then add the or token. That is no good, though. Consider what would happen if a user named a variable orchid. Scanner would see the first two letters or and immediately emit an or keyword token. This gets us to an important principle called maximal munch. Maximal munch. When two lexical grammar rules can both match a chunk of code that the scanner is looking at, whichever one matches the most characters wins. So that is the principle. We're always going to decide, right, when there are two different ways of interpreting and consuming characters in order to recognize a token, whichever one matches the most characters wins. That rule states that if we can match orchid as an identifier and or as a keyword, then the former wins, namely orchid. This is also why we tacitly assumed previously that less than or equals to should be scanned as a single less than or equals to token and not less than followed by equal. And you will remember in the previous video exactly that, where over here, when we encounter the less than character, we first check if the next character is an equal sign, then it should be considered a single token of less than or equal to, not less. And similarly for bang and bang equals, equals and equals and greater than or equal to, and so on. So anyways, okay, so that's good to know that we were making use of this principle called maximal munch before, even though it wasn't made explicit. Maximal munch means we can't easily detect a reserved word until we've reached the end of what might instead be an identifier. After all, a reserved word is an identifier. It's just one that has been claimed by the language for its own use. That's where the term reserved word comes from. So we begin by assuming any lexeme starting with a letter or underscore is an identifier. And you'll recall the style the author's using here is the blue and teal, I guess it is the new code that he's introducing. And the rest of it is just the context, so you know where you are, which is in fact quite helpful. So we wanted to get back to our this, right? Okay, so we are here, right? That's the context here. We are in this area over here, and we had implemented if is digit, then we're going to treat it as a number. So now we are going to need a new one, else. So this should be elif is alpha. If the character is alpha, then we are going to use scanner, the identifier proc. Now, we don't have either is alpha or identifier. Now, I know there is a built-in, there is this built-in is alpha ASCII in nim, checks whether or not character C is alphabetical, but it looks like the author here, he defines is alpha this way, right? So it's A through Z lowercase or A through Z uppercase or an underscore. And I believe I checked this function at one point, and we're not going to get true for is alpha ASCII if we pass in an underscore. So we can't just use that. So we're going to have to define this is alpha, and we'll do it up above over here. And we'll just say is alpha takes a char, however you want to say that, and it returns a bool, and it is equal to, so we'll make use of is alpha ASCII, right? Or it's equal to, the underscore. That looks good to me. So now we have that is alpha. Then we're going to treat it as an identifier. We don't yet have that, so let's implement it right below number. And we'll say, so how does he define this? So while is alphanumeric, peak, advance, right? So advance as long as you continue to see alphanumeric characters, and then you're going to add, you'll consume all of those, and then add an identifier. And then is alphanumeric is just defined in terms of the other functions he's defined, is alpha and is digit. Is digit is one that we already have. As you can see here, we've made use of it. So we'll define, this function first, is alphanumeric. So actually we'll do it below over here. And I think we can get by with a little bit of copy pasta. So is alphanumeric is alpha or is digit. Is digit. Okay, and now we need to actually implement the identifier for the scanner. So this is going to be identifier, and you'll recall S, we have that using clause above, where anytime S is encountered, that's the scanner. Okay. Now, so identifier, and this will be equal to while is alphanumeric peak, right? While that's the case, then advance. And I'm literally just copying what he's done here, and then add token, and this will be identifier. Now I am going to move this below since I'm making use of those functions. What happened here? There we go. Not sure why when I move things over in visual mode like that, the indentation gets screwed up. I'll have to look into my Vim configuration at some point to figure that out. Not important for now. Now, obviously, this has not yet dealt with reserved keywords, right? So this is just assuming that everything we encounter is an identifier, which is obviously not the case when we get to the world of reserved keywords, which is this next part. Okay, so that gets identifiers working. To handle keywords, we see if the identifier's lexeme is one of the reserved words. If so, we use a token type specific to that keyword. We define the set of reserved words in a map. So we got to figure out, we have not used a map yet in NIM. So let's go ahead and take a look at what that looks like. And some quick searching before revealed that it's a table. The tables module implements variants of an efficient hash table that is a mapping from keys to values. Table's the usual hash table. Here's an example. You could have this mapping you call to table, and here's the basic usage. Create these two arrays, then you zip them and fill up the table. Right, so there's an init table. Now in our case, this is going to be a static, we know what all of these keywords are already, right? So given that that is the case, we can just statically, right, define what that table is, matching everything that the author has over here in his keywords. So I think what we'll do is we will put that into the scanner definition, right? So we'll say, now this probably could be a standalone, just top level variable that's defined. I don't see why not. Right, you could argue that it doesn't really make sense that this sort of live scanner object is going to have these static keywords, like it doesn't really belong there. I guess we could do that, right? We could say, let's see if that works. So we'll say var keywords. This is a table of type string to token type, and it equals all of this. And let's cheat a little bit by copy pasting over here. Let's see how that works. And we'll just have some stuff to get rid of here. Let's line that up, and we'll go into visual block mode. We will go back, delete all of that, and then this will become that. Same thing there. I'm sure there's a faster way to do this, but my Vimfoo It's not quite there yet. Okay, had to stop the recording there for a second, but I think what we're going to do now is see if there's a simple enough way to, let's see if we can just replace every incidence of what? I want to replace that with a comma. No, that didn't work. I want to say, what I'm trying to say is replace every this. I might need to escape this. Replace every this and this with a comma. All right, total fail. Let's just do this. Simple enough. I'm sure there is a faster way to do this, and we will figure that out at some point. In any event, some of these also have backticks, which we'll need because the names of our tokens are themselves reserved keywords in the host language, I guess it would be called here, NIM. And so what I'm going to do, so I can open this up and look at it at the same time, that's exactly what I wanted to see. I wanted to see this here, this whole thing. And so what we want to do is, excuse me, not that, not that, these up over here. So, okay, so, and, right, this right here does have the backticks. So we will surround those. Class doesn't have it, else has it. So we'll do that. False will have it. So we'll need it there. Whoopsie. So false will have it. For will have it. Fun for function doesn't have it. If will have it. We'll surround that. Nil will have it. Do that. Or will have it. Print will not have it. Let's see what else we got. Return will have it. Super will not have it. This will not have it. True will have it. Did that wrong. So true will have it. Var will have it. Again, I screwed it up. Visually select the inner word. Shift S, that, and then finally while will have it. Okay, so now we have our keywords. Okay, great. So now we have them. Let's see if this will work. Then after we scan an identifier, we check to see if it matches anything in the map. Okay, so let's go, where are we? I'm going to be here in our identifier function. proc. I'm not sure why I wasn't able to jump to that, but it's over here. So we need to add in let the text equal the scanner's source at the start until I think we need that, right? That's how we did it before. Current -1. And I was surprised to find out. I'd love to hear from people in the comments. I would have wanted to reach for something like get or default, or some sort of function defined on a table that would just return nil if it didn't exist, right? Because obviously we want to, we don't want to like throw an exception or whatever in the case where the key is not in the table. And maybe some variant of that would work. I'm not sure if the types would quite work out correctly. I think there's several variants of the get or default. There's one where you don't even pass in a default, but you just get a default, whatever the default value is for the type of value. So, for example, if you had a table of type string to int, and you did get or default, and you passed in some string that was not a key in the table, and then without specifying a default, you would just get 0 because that's the default value for an int, right? And for Boolean, I guess it's false, whatever the case may be. But just kind of Googling around a little bit about the proper usage of table in Nim, and it very well could be that I misread. Again, I'd love to hear correction in the comments, but it seemed like the idiomatic Nim way of doing this is just to check if the key is there, and if it is, then you're good and you can get it. Otherwise, don't. So in other words, it would be if keywords has key text, right? Then, well, first we'll declare a variable called the type token of type, token type. And we will, I guess, leave that uninitialized, and then we'll say if it has it, then the token type is equal to the keywords at that, right? Else the token type just equals identifier. Now let's see if this will even compile. Let's build it. Invalid command build. That's because we want nimble build. Still figuring out the tooling here. So this does not work. Undeclared identifier table. Right, we need the import. So let's go back up here. And tables, I believe it is. Try this again. Okay, ill-formed AST. Ill-formed AST. I'm sure there's something very basic that's missing there. So let's go check that out on line 81. Line 81. What do we have here? Well, for one, we need toTable. And what else are we missing here? And class, else, false. This all looks good, I think. Oh, this needs to be that. Not a comma, we must have missed one. Now let's try this again. Undeclared identifier fun, line 170. I probably did fun instead of func. Yeah, That's not going to work. Try it again. Undeclared identifier found line 174. Did the same thing here. You can just never... Every language has its own thing. FN, FUN, FUNC. No language is the same. Okay, so that looks good. And again, I think it does make sense to have the keywords just stand alone, right? Let me know what you guys think about that. I initially thought, oh, I'll just stuff it into the scanner, like so. Like I would say, put it here, and then maybe in the initializer, do something like, okay, the keywords equals, and start initializing the whole thing. But since this is static, it doesn't really make sense, right? This isn't like a dynamic thing that depends on the particular instance of the scanner object. So it doesn't really make sense to me. The other thing I was messing around with was I was curious about what the story is for auto formatting in NIM. Seems like, to the best of my knowledge, it's kind of an unsettled story. I really like auto formatters that are like pretty opinionated and I guess more so deterministic in the sense that it will always give the same output given the same source. It just really helps when working on teams, takes any sort of debate out of it, even if you may have your own preferences that are, configurable with that particular formatter. Anyway, so one of them is NPH, which seems to have the philosophy of like black. And I'll open this up real quick because it's still like a small project, but seemed good. 34 stars, but active, recent releases, and it's an opinionated source code formatter following the great tradition of black, prettier, Clang format, and other AST-based formatters. It discards existing style to create a consistent and beautiful code base. That's what I want. So, I assume there will be some warts and whatnot. We got some open issues closed, but it seems like the jury's still out on what will be the winner here. I know that there is prettier, and I've used it, although I was a little confused as to how that worked. But I don't even remember how I used it. But the point is that this does seem to work. And we can take it out for a little spin here. Let's see what it would do with the following. So let's save that. Run NPH on this again. And you'll see, yeah, it gives us consistent spacing, indentation, and all of that. I'm curious what would happen if we join these lines. Would it have an opinion as to that? It does want to put it on a separate line. Okay, cool. See, I don't know what the conventions are, what the kind of style is for NIM. Obviously, you learn it over time and sort of naturally do it, but it's not something I want to think about. I want to just be able to use the tool and apply it as a pre or post commit hook or something like that. So in any event, we now have the logic there for how to work with an identifier. And one thing we could have done a little bit differently here, curious what people's preference would be, we could just say this defaults to identifier, and then only if we have the key will it be something else. It really, I don't think makes a big difference, but I could see the argument for my original way being a little clearer, right? Because you can sort of read it straight down. You can say, okay, I know this is uninitialized and something here, presumably this if else is going to set it. To me, that's, even if it's more lines of code, it's a little bit easier to read. But the point is we can now run this and assuming we've implemented it correctly, we should see that, we get, for random identifiers, they are correctly interpreted as the identifier token, whereas And let's pull up our full list again, right? If it is one of, and, oh, and is an identifier. Something's wrong there. And is an identifier. Huh. No, and should be and. What did we do wrong here? Advance. Get it from the start. If the keywords has key, boy, we better check what our keywords equals. Echo the keywords are keywords. Save that. Run this again. Or, okay, so it has the keywords. And it has and. Okay, so and is not and. And is an identifier, but that's not correct. Let's see, does it have this? Echo found keyword for this text. And found keyword for and. So what's the problem? Oh, duh. The problem is we didn't change the following, which is that this needs to now be the token type, right? Because in the beginning we only had the case of identifiers working, but not the case of the reserved words. So now foo should be an identifier. Let's get rid of all this other crap because it is a lot of output. Let's run this again, and we'll say foo is an identifier, and should be and, good, or should be that. Let's go back up to our words here. We have class is class, false is false, for is for, fun is fun, if is if, nil is nil, good. Or is or, print is print, return is return, super is super, this is this, true is true, var is var, and finally while is while. Beautiful. And we should also check the case of the maximal munch, right? So we know that or is going to be or, but what about orchid? Still an identifier. Good. The logic is good. Correctly implemented that principle of maximal munch. It's really it for this video. Kind of quick. I think I'm really enjoying the language. As I mentioned, I had this kind of 6 to 8 week hiatus. I don't know exactly what it was. And clearly, just a couple months ago, I was still very much a noob to the language and still am. And so I haven't yet reached that point where, if you've used the language for like a few years and then you take a little bit of a break, getting back to it is kind of a breeze. It's like, just jumping back on a bike. It just comes naturally to you, even if you may be a little bit rusty. And I certainly haven't reached that point yet with NIM, right? It still kind of fits and starts, and I'm still very new to it. But even though that's the case, I think it's a real testament to the language and the fact that the syntax is kind of so fluid and lightweight that even in a situation like this where I'm still pretty new to it, being away from it for 6 weeks or whatever, I'm still able to pick it back up relatively easily. And to me, that's an amazing thing because the language more or less looks like and reads like Python, yet you have static typing, this more advanced type system. You have better performance. You have all of these other guarantees and features of the language that you don't have in a language like Python. And you really haven't, you don't have to make a trade-off where, you get all of that in exchange for being bogged down with a really sort of burdensome, heavy language. Like the syntax is really just very lightweight, straightforward, and it just feels like a really enjoyable language to work with. Curious if people watching have had a similar experience. I think one thing that's going to be really fun to do is, I want to treat this like a real world sort of exercise. And what that means is, I think for this to be complete, once we feel that we have gone through, I guess, most of the book and we have the functional interpreter, it'll be great to circle back and see like how easy is it to refactor, right? I think like the ease of refactoring is a great thing to check in a language, because so much of the time we spend with code is not just like writing the original code, but it's, you get these sort of foundational pieces in place and you build up a sort of living, breathing code base that hopefully can accrue more and more functionality in code without becoming more complex. And to do that, you sort of refactor over time, sometimes major refactor, sometimes small. But the question is, what facilities does the language offer to enable you to refactor confidently, right? Like refactor in a way where you're confident that the functionality and the logic isn't changing. Obviously, testing is a part of that, but the language constructs themselves can, right? There are languages that are easier and harder to do refactoring in a way that you can feel confident about. And so I'd love to see what that feels like in NIM. I suspect it's going to feel good, but we'll see what that's like. And so we'll try to follow the path of, make it correct or make it right, make it fast, make it beautiful. So we first want to get the basic functionality working. Then we want to see what we can optimize, if that's something we even pay attention to in this case. I don't know. I think we're probably just going to make our code as, performant and efficient as the author did in the book. But then finally, there's make it beautiful. And so maybe we won't quite get there. But again, I would at least like to kick the tires and see what the refactoring experience in NIM is going to be like. Anyways, that's it for this video. Once again, any feedback or suggestions are greatly appreciated. I did hopefully make some improvements to the video. It's still pretty chaotic and stream of consciousness, but that is the intention. I increased the font size since I got some feedback about that. Hopefully it's a little bit more readable for you all. Yeah, any other feedback, suggestions, greatly appreciated in the comments. Leave a like and subscribe, and I will see you all in the next video.